For 49, we're trying to figure out if the triangles are similar. So there's 3 ways to prove similarity. It's either going to be angle, angle, side, 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 or side, angle, side. So for this one, right away, we know that there are vertical angles. And then you also have these 2 parallel lines. So if you choose one other line to be your transversal, you are creating some alternate interior angles, making these similar by angle, angle. For the next one, we're going to solve for A and B. So I need to set up a proportion. So I'm noticing that this side and this side correspond. So I can make that one of my fractions. So 6/21 equals, and then A would correspond with 11. And then when I start to solve, I get 21A equals 66, and I divide both sides by 21. That just simplifies, and I can divide them both by 3, so that would give me 22/7. When I solve for B, I'm pretty much doing the same thing, so I'm going to start with that 6/21 again, and then B corresponds to 10, so that would equal B/10, and then I would go ahead and cross multiply, so 60 equals 21B, and I divide both sides by 21. I'm going to write it down here. So B equals 60/21. I can divide them both by 3, and so I get 20/7. For 51, I'm checking if the triangles are similar. So I'm going to start with the sides, and I'm going to match up the smallest with the smallest. So 4/6 is 2/3. The largest with the largest, 6/9 is 2/3. Since those match, that's a good sign. And then here I have some vertical angles. So these are similar by side, angle, side. For 52, we're just going to complete the similarity statement. So if they name their triangle ABC, so AB is going down this side that has no numbers on it. And then BC, I'm noticing, is the smaller of the 2. So I just want to follow that pattern on my second triangle. So this would be the side with no number on it, and this would be the smaller of the 2, and so that would be DEC. Oops. So for 53, I would check to see if the sides are proportional to figure out if they are similar. So the smallest is 6 and 10. 6/10. I can divide both by 2, so that would be 3/5. The middle side is 8 and 12. 8/12, I can divide them both by 4, which is 2/3. Since these don't match, we just say not similar. For 54, we have Ken, who is standing so far from a mirror. So here's Ken, here's my mirror, and then he is looking into the mirror and he can see a tree. He is 5'11". He's 4'2" from the mirror. The mirror's 9 feet from the tree, and we're trying to figure out how tall the tree is. I want to start by converting all of these to inches. So I'm going to do 5 times 12, and then I'm going to add on the 11. So 5 times 12 plus 11 is 71 inches. Same thing down here, 4 times 12 is 48, plus 2 is 50. And then lastly, 9 times 12 is 108, I believe. Yes. Then I'm going to set up a proportion. So I'm going to do 71/50. And then I'm going to follow that pattern. So x/108. Cross multiply. So 50x equals 7,668, divide by 50, x equals 153.36. So this is in inches. It doesn't specify the height. I'm going to go ahead and divide by 12 to put it back into feet, and that is about 12.78 feet. And then this last one is very similar to the project we did. So we have an elf on the shelf that's 10 inches, and then we have Will Ferrell, and we want them to appear the same size in our photo. So here's my camera. Here's the elf on the shelf, which is 10 inches tall, and then Will Ferrell is 6 foot 3 inches tall. We want the elf to be 2 feet from the camera, and we're trying to figure out how far Will is going to need to be from the elf, which I'll get to at the end. So to start, I'm going to convert everything. So this is actually 24 inches, and then Will Ferrell would be 6 times 12 is 72, plus 3 is 75. So I'm going to start by setting up that proportion. So 24 over x equals 10 over 75, cross multiply, and I get 1800, divide by 10, and I get 180 inches, which I'm going to go ahead and put back into feet. So it's 15 feet. Now, the important part about this question is I want to know how far he's standing from the elf, not the camera. So I need to take this 2 feet that we started with and subtract it out. So he's really only going to stand 13 feet from the elf, 15 feet from the camera.